Okay. Uh, in many ways, algebra, the study of algebra, can be broken down into really two categories, and that's operations and sets. For example, what are some of the operations that you do in mathematics? Add, subtract, multiply, divide, exponents like square roots. Parentheses aren't an operation, they're a grouping. That'll be like square root, exponents. How about absolute value? Notice that there comes a point where you can't really think of much more, can you? And that's what's interesting as we move forward in mathematics. Calculus is all based around really two operations. And those two operations are the derivative and the integral. So we add to this list of operations. There are other operations I'm going to show you. On Friday, I'm going to show you what we call the inverse operation. Okay? But when we refer to sets, you guys are always used to thinking about this set, all real numbers. But there's different ways to operate back and forth, and there's different properties. For example, addition. Are real numbers commutative under addition? Can you switch them around? How about multiplication? How about subtraction? How about division? No. So you see, they have different properties. Well, here's another one. You may say multiplication is always commutative. No, it is not. I'll give you an example. That's a matrice. Matrices are not commutative under multiplication. If you were to take these two matrices and multiply them together, you can multiply those together. Switch them around, okay, and I'm sorry, am I doing it incorrectly? This is a bad example. Okay, right now, you cannot take these matrices and necessarily multiply them together. If you were to change the size, then you could. Okay, so matrices are not commutative under multiplication. There's a lot of things you can add to this list of sets, and that's what makes mathematics more interesting as you go forward. Today, we're going to talk about functions and how we operate on them and the properties that they have. So, if you see this notation, f plus g of x, that means you take f of x and add it to g of x. And if you say f minus, you say f of x minus g of x. If you see multiplication, you do f of x times g of x. And if you see divided, you do f of x divided by g of x. Now, one of the questions is what happens to the domains of these functions as you add or subtract them? And here's what we have. Suppose that the domain of f was from 0 to 2, and suppose that the domain of g was from 1 to 3. The domain of the functions together, added, subtracted, or multiplied, would be the intersection of the two, the overlap. So from 1 to 2. Union means it includes everything shared in both sets, so 0 to 3. But intersection means the overlap between the two, 1 to 2. So the way that we write this is domain of f intersection domain of g. Domain of f intersect domain of g. So on and so forth all the way down. Except we have a problem when we get to the bottom. F of x divided by g of x, what can't you have in the denominator? So you can't have g of x equal to 0. You need to exclude that from the domain. So let's try a basic example. It says find f plus g of x. Well, f plus g of x is going to be equal to f of x is x squared, g of x is x minus 1. I simply add them together. X squared plus x minus 1. Pretty simple, huh? F minus g of x. I'm going to take f of x and subtract g of x, so I'll have to distribute the negative sign. X squared minus x plus 1. If you multiply them, what is x squared times x minus 1? X to the third minus x squared. And if you divide them, we get x squared over x minus 1. Okay, for the domain, you need to consider the domain of both functions. Don't make this more complicated than what it is. I know that we didn't do very well in the domain part of our test. I don't know why that is. Either you didn't prepare well enough or I didn't do a good job enough teaching. I don't know what that was, but I know that this kind of left our brain. It needs to come back during this unit, so we'll cover some examples again. X squared, what does that look like? What's the domain of a parabola? All real numbers. What does x minus 1 look like? It's a line, domain of a line. What is the overlap between all real numbers and all real numbers? All real numbers. And you can tell if you look at the new function, x squared plus x minus 1, you get a parabola, and the domain is all real numbers. So the overlap between these is all real numbers. So from negative infinity to positive infinity. And it's going to be that one for, if it's that way for addition, it's that way for subtraction, and for multiplication, and for division, except we have to be careful when we're dividing. Will sees that we need to exclude a value. Where is g of x equal to 0? X can't be 1. So we exclude 1 from the domain by writing it like this. If you'd like to write it like this, that's fine as well. Okay, for the next one, again, we'll lay out f plus g, f minus g, f times g, and f divided by g. I have 2 square roots. Can you add the inside of the square roots together when you add these? Can you take the square root of 4 plus the square root of 6 and get the square root of 10? No. So when you don't know how to do a more difficult problem, make an easy problem and see what the property is. Square root of 2 minus x, simply plus the square root of x squared minus 9. That's what you have. F minus g. Square root of 2 minus x minus square root of x squared minus 9. How about when you multiply 2 radicals together? Do you multiply the insides? Yeah, you do. So let's multiply these insides. X squared times negative x to the third. X squared times 2, 2x squared. 9 times, or negative 9 times negative x, positive 9x, and negative 9 times 2. So there's our square root. When you divide 2 square roots, can you write it as 1 square root? For example, the square root of 6 over the square root of 3. Is that the same as the square root of 2? Yeah, you can write it as 1 square root. So I will write this as 1 square root. We have the square root of 2 minus x over x squared minus 9. A lot of people don't like the square root in the denominator. You can leave the square root in the denominator. if there's a variable. If you had just a 5 in the denominator, you could not leave that. Okay. All right, the domains. I need extra paper, so I'm going to insert this. You don't have that, so you can take out a sheet of paper if you need it. Otherwise, just watch. 2 minus x, and then we have g of x is equal to square root of x squared minus 9. Is the domain of these two functions all real numbers? No, you can't take square roots of negative. So therefore, we isolate it. We say 2 minus x must be greater than or equal to 0, must be positive. And you solve that, and you get negative x is greater than or equal to negative 2. Very good. So your interval would be from negative infinity to positive 2 bracket. Look at this one, x squared minus 9 greater than or equal to 0. Can you solve a quadratic inequality by, just basic algebra like this? You have to make a graph. Exactly. What does it mean for a graph to be greater than 0? Or above the... That's probably my phone. It's probably going dead. How did I know it crossed at negative 3 and at positive 3? Because, yeah, that's square root of 9. It also factors to x plus 3 and x minus 3, right? So if you factor it like that, then you're going to be good to go. So if you want to answer the question, where is this thing greater than or equal to 0, you would look for this portion right here and this portion right here. So as an interval, that would be from negative infinity to negative 3, union with 3 to infinity. So my question to you is this. What is the intersection of those domains? Because the domain of these functions added, subtracted, or multiplied together is going to be the intersection of this. Where's the overlap? If you can't see it, look at a graph. Yes, it is. If you can't see it, make a graph. Negative infinity to 2 is like this. Negative infinity to negative 3 is like that, and then 3 to infinity is like that. So you tell me, is there overlap right here? 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 Yeah, so this is the region where it overlaps. So therefore, your domain is going to be from negative infinity to negative 3. So I could go back to my original problem, and I state the domain. The domain was a little bit of work here, but it's going to be from negative infinity to negative 3. And it'll be that same one all the way down. Except for the last one. Can't divide by 0. What gives you 0 in the denominator? 3 and negative 3. Is 3 included in this domain? No. Is negative 3 included in this domain? So I have to exclude negative 3. So I can simply do negative infinity to negative 3 parentheses. And then I'm good to go. No, that would not suffice. Thank you. Thank you. Okay, copy down these two graphs as best you can. Yeah, other people need me to win. Okay, copy down the graph as best you can. Height of -3 here to -5. Should I blow it up? Should I make it bigger? How's that? It is pretty useful. I love having a smartboard. I have to. I love I don't have to walk into class with transparencies and markers. Simply just touch your board and it all pops up. Been down that road. Yeah. Oh. Maybe because you put a virus on that computer. Oh, you checked it. We know what that. Nice. We heard you confess. Okay. So what I want to do is in blue. In blue, I'm going to write f plus g. Okay. So what's going on? Oh. Okay. In blue, I'm going to graph f plus g. Never mind the directions. I've changed them because it seems like people get confused every year, so I'm finally going to change this. If I want to graph f plus g, I'm going to add these functions together. And so what that means is I need to know where to put the y value for an x value of -6. So all I do is I add the outputs at -6. What's the output of f? 4. What's the output of g? -3. Add those together, you get 1. Let's go to -5. What's the output of f? 4. What's the output of g? -3. Add them together, you get. Okay. Well, we'll try again. I have an x value of -4, okay? So I want to know where should I put the dot for -4? Where does it go? What height does it go? So what I have to do to find that out is I add the function value at -4 to the function value for g at -4. So the height of f is 4. No, I'm not averaging them. I'm adding. Okay. Well, try one more time. Mercedes, what's the height of the function right here? What's the height of the function? How about here? 4. How about here? How about here? Right? Okay. What's the height of G right here? See that? We're just going to add those values together. So, look, I want to add these two functions together, okay? We have negative 6. So I know where to plot the point at negative 6. I take 4 and add it to negative 3 to get 1. Okay. How do you know what? Well, you want to do them for the whole thing. Okay. All right. For negative 4, I plug it in. 4 plus negative 2. 2. For negative 3, I add 4 and negative 1, and I get 3. For negative 2, I add 0 and 4, and I get 4. For negative 1, I add 1 and 4, and I get 5. For 0, I add 1 and 3, and I get 1, I add 1 and 2, and I get. For 2, I add 1 and 1, and I get. For 3, I add 1 and 2. For 4, I add 1 and 3, and I get. And for 5, I add 1 and 4, and I get. And then I get 5 all the way across. So this graph looks like, when you add them together, that's what you get. So F plus G is that shape. We'll just do 3 points for the next one so you can get the idea. G minus F. So now I'm going to take G and I'm going to subtract F from it. What is G? Minus F. G minus F. Negative 7. Again, for negative 6, G minus F. Negative 7. For negative 5, G minus F will be negative 3 minus 4. Negative 7. And then you move up. At negative 4, G would be negative 2 minus 4 would be negative 6. And so on and so forth, and you would continue to make the same kind of sketch. So that's how you do graphical addition and subtraction. Yeah, it's a good time. You can even make up more problems and practice on your own tonight. Here's your assignment. Well, I always thought it was kind of a, speaking of double standards, we have this acronym, DEAR, drop everything and read. Well, or you get done with a test. Everybody will say, when you're done with your test, just take out a book and read. But whatever happened to, hey, if you got some spare time, go ahead and take out those math problems you want to work on it. Yeah, well, that's my frustration. There's not that time. Why not? I always felt different growing up because when I got done with my homework in other classes, I didn't have anything to do. I'd take out 5 math problems from the back of the book that I wanted to work on. Yeah. I still do it. When I get bored at a meeting, yeah. Why do you read?